Welcome back to Math 30-1. We're looking at stretches. We've completed the vertical stretches, so now we're going to look at horizontal stretches. If you consider horizontal, we can think or recognize that what we're altering here is the x component, not the y component. So we have to look at what x component would we need to produce the same y component. So in terms of our equation or function notation, what we have is y is equal to f of bx. We have to multiply our x component by some variable so that we can produce the same y component. Now, so what's changing here is x. So let's look at creating a second table of values. Excuse me, let's put that back, and we will build that second table of values. We have x, and this is our altered x, so for our new or our stretched function, and our f of x. So we don't want to change our f of x. It's 2, 6, 4, 4, and 0. But we want to ask ourselves, in this altered situation, and I'm going to realize I didn't put my b in there, that's f of bx. What x component do I need to produce that same output, or the same f of x, or the same y component? So if I started with -2, -2 gives me +2. I need to have, if my b value is going to be 2, I need to have a -1. So -1 times 2 gives me that -2, and I then will get my output of 2. What do I multiply? What value do I multiply by 2 to give me 0? Well, that's still 0. So again, we have an invariant point. What do I multiply by 2 by to give me this x value of 2? That's 1. So in my stretched function, I need an input of 1 to give me the output of 4. I need to multiply 2 by 2 to produce this x component of 4, which are my input of 4, which will give me 4 out. And then again, it's 3. And so what I want you to notice is that with my b value, my x component changes or is stretched by a factor of 1 over b. So the x changes by the inverse of that parameter b. So let's graph that. We're going to graph it in red. So we have -1 producing the output of 2. We have 0 producing the output of 6. And again, you can see we have that invariant point. We have 1 producing our output of 4. And we have 2 producing the output of 4. And then we have 3 producing our output of 0. We'll just, okay, so my line is red here. Connect these points so we can see what our stretched graph looks like. And just see if I can't produce, a straighter line here. And I didn't get it quite straight, but like so. And I'm going to, I inadvertently erased my original function, so I will try and put that back so we can see what we had originally. And again, quite straight, but okay, that's not what we're going to do, so we're going to stop this. I'm going to stop the recording, correct the drawing, and then I will start again. Okay, so I'm back. I apologize for that. So we can see that we've created, or we've done our horizontal stretch, and when we have a factor of 2, our graph is actually stretched by a factor of 1/2. And I just want to label this f of bx, and the original black graph in black is f of x. So we can see that the stretch actually has resulted in an image that is more compact or tighter to the y-axis, and it's important to recognize that when we're inside the function, or when we're working with that b parameter, that we have an inverse relationship in terms of our stretch. So unlike our vertical situation where there's a direct relationship, we now have an inverse relationship. So let's scroll down here. I've got a second graph, and let's let the b component, or the b parameter, instead of being greater than 1, let's make it a fraction, so 1/2 instead. So we're going to graph f of bx again, only in this instance we're going to let b equal to 1/2. And we ask ourselves the same question: what what input value do we need? And I'm just going to change this black to back to black. And what input value do we need to produce the same output? So, oops. And I apologize for my awkwardness with the tools again today. I thought I had fixed that up, but we're just learning. So what x component do I need to put in to get the same output? So if I'm multiplying by 1/2, if I need to have a -2 to produce 2 out, I'm going to have to take and multiply -4 by 1/2 to give me that -2. And I'm going to take 0, to get 0 out, I just multiply by 0. If I'm going to take and get out a 2, or to get out the 4, I need to be having a 2 going in. If I take, what number do I need to multiply 2 by to give me, what number do I need to multiply 1/2 by to give me 2? And that's going to be 4. And this will be 8, and this will be 12. And so notice in this instance, I have a direct relationship where it's b as, it's still an inverse relationship, 1/b, so 1/1/2, which gives me 2. And so the multiplication factor, or the stretch factor, is actually 2 here. Let's graph this and see what it looks like. And so I have an input of -4, which gives me 2 out, input of 0 to give me the 6 out, an input of 4 to give me the 4 out, and again an input of 8 to get that 4 out again, and finally 12. And we'll connect these up. I just need to change the color. And give me a second here. We'll finish this up. And so we have, well, just a little cautious of using this, but we're seeing worked out okay this time. Didn't have to stop the whole thing to fix it up. And that needs to be lifted up. So here we go. So again, not beautiful, but we still, it gives us the idea. And we have in this instance f of bx when b is 1/2. And so the stretch factor is 2, and we can see that it's been stretched out horizontally as opposed to being made tighter to the y-axis. And we have that, again, that inverse stretch, or that inverse relationship for our stretch factor. I'm going to stop now and let you get on with the rest of your studies for lesson number 1.1.2, reflections and stretches.